Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we are going to talk about the distribution of the sample proportion. It's a lot similar to the distribution of the sample mean, except this time we're talking about proportions. The statistic that we're sampling is the proportion. All right, so suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristic. Then the sample proportion, which we call p hat, that's this right here, we read p hat is given by, and here's the formula for it, p hat is equal to x over n, where x is the number of individuals in the sample with that characteristic, and n is the sample size. So the sample proportion p hat is a statistic that estimates the population proportion p. So p is our population proportion, all right? So we got some new terms, p hat, which is the sample proportion, and p, which is the proportion of something happening, okay? So it's whatever that we're measuring. So here's an example. The Harris Poll conducted a survey of 1,200 adult Americans who vacationed during the summer and asked whether the individuals plan to work while on summer vacation. All right, this is so me, y'all. I'm always working on summer vacation. So I would be one of those who say yes on here. So of those surveyed, 552 indicated that they plan to work while on vacation. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. So we want to calculate the sample proportion, which is p hat. And so remember, the sample proportion is equal to x. That's the number that indicates that specific characteristic. And in this case, the characteristic is those who plan to work while on vacation, which it was 552, over n, which is the number that was surveyed, which is 1,200. So that's our x over our n. And if you divide that out, 552 divided by 1,200, you end up getting 0.46. So the sample proportion will be 0.46. And that just basically means that approximately 46% of adult Americans who vacation during the summer plan to work while on vacation, all right? So that's 46% of adult Americans who vacation during the summer plan to work while on vacation. And that might be me, y'all. All right, let's keep going. All right, here's another example. Based on a study conducted by the Gallup organization, 76% of Americans believe that the state of moral values in the United States is getting worse. Describe the sampling distribution of the sample proportion for samples of size n equal 10, n equal 25, and n equal 60, all right? So now we're getting at this concept of the sampling distribution of the proportion. So what we want to do, and this is just a breakdown of what that would look like. So for n equal 10, that means we would survey 10 people and we would indicate whether the characteristic that we're interested in exists or not. And so in this case, the characteristic that we're interested in is Americans believe that the state of moral values in the United States is getting worse. If they say yes, it's indicated with a 1. If they say no, it's indicated with a 0, because is either a success or it's not a success. So we typically use 1 for yes and 0 for no. So then you would take a sample of 10 people, you would survey them, and then you would take the proportion of those that said yes. So in this first sample 1, there were 7 that said yes. So the proportion would be 7 out of 10 because 10 people were surveyed. All right. And then you would just repeat that process, and you would keep repeating that process for a lot of times. And then that would give you your sampling distribution. All right. So if we did it for n equal 10 and we repeated that process, this is just a like an estimate of repeating that process 2,000 times. This would be your sampling distribution of the proportion, the sample proportion, all right? This is what it looks like. It is skewed left, can you tell? Because it has a longer tail on the left side. So this is skewed left. Our n is 10, that's our sample size. The mean here, the mean of our p hat is 0.76, all right? And then the standard deviation, which it doesn't show on here, the standard deviation on this one ends up being 0.136, all right? And then we would do that again, but this time we would take 25 samples and repeat the process. You would calculate the proportion for each one that you do it. You would do it 25 times, and this is the model that you would get. And as you can see, this one is still skewed left, but not as much as this one. It's still skewed left. Mean is still 0.76, so your mean happens at 0.76. And in this one, your standard deviation ends up being 0.086, okay? And then we will do it one more time because it told us to do it 3 times. And there's a model that does this and produces these models for you, these images for you. And you can use StatCrunch, but we're not going to go through all of that. I'm just giving you the end result. If we did it n equals 60 times and we created the distribution of those sample proportions, this is what it would look like. And as you can see, this one is approximately normal. It's not skewed left like these, okay? Your mean is still 0.76. And on this one, your standard deviation is 0.054. So there are a few things that we notice when we look at these 3 models. First of all, you notice that the mean is the same on all of them. And the mean actually ends up being the same. The mean of the distribution of our sample proportion ends up being the same as the proportion of the population, okay? And then if you notice the standard deviation, it decreases each time. So it goes from 0.136 to 0.086 to 0.054. So what we can do is we can conclude a few things. One is the shape. As the size of the sample increases, the shape of the distribution of the sample proportion becomes approximately normal. So as we saw when we got to n equals 60, our graph was normal. The center of the distribution of the sample proportion equals the population proportion, P. And then the spread, the standard deviation of the distribution of the sample proportion, decreases as the sample increases. And that's kind of similar to what we saw also with the sampling distribution of the sample mean. Okay, so there are a few characteristics of the sampling distribution of p hat, which is the sample proportion. And the first one is that the shape of the sampling distribution becomes normal if n times p times 1 minus p is greater than or equal to 10. Now, this is different than the sampling distribution of the sample mean, because on that one, the magic number was 30. If you had a sample size of 30 or bigger, then it would be normal. And on this one, you have to multiply n times p times 1 minus p, and it needs to be greater than or equal to 10. All right. Also, the mean of the sampling distribution, p hat, is equal to p. All right. So the mean of the sampling distribution of your sample proportion is equal to p, which is your population proportion. And then the standard deviation of the sampling distribution of p hat is found by taking the square root of p times 1 minus p, all divided by n. All right. So let's use this on an example. So suppose that the proportion of Americans who believe that the state of moral values in the United States is getting worse is 0.76, and that's based on a study conducted by the Gallup organization. Suppose we obtain a simple random sample of n equals 60 Americans and determine which believe that the state of the moral values in the United States is getting worse. Describe the sampling distribution of the sample proportion for Americans with this belief. So one thing here is now we have a sample size. So whenever you have a sample size, and you're taking multiple samples, you are now dealing with a sampling distribution, okay? So we want to determine the distribution. So basically, we want to know if it's normal or not. And in order to know if it's normal, we have to do the n times p times 1 minus p. And in this case, our n is 60. Our proportion is the 0.76. And then 1 minus 0.76. If you subtract that, that ends up being 0.24. So you do 60 times 0.76, that's a 6, y'all, times 0.24. And if you multiply that out, you actually end up getting 10.944. All right, and the number you want to check that up against is 10. And that is greater than or equal to 10. So since that's greater than or equal to 10, this is a normal distribution, all right, since that's greater than or equal to 10. All right, well, since it's normal, then what we want to do is we want to find the mean and the standard deviation. So I am going to clear this because I need more space to find both, all right, and I'm going to say that the mean of p hat is equal to the population proportion, which is 0.76, all right. That's this value up here that's given in the problem, and then also, the standard deviation of p hat is equal to the square root of p times 1 minus p all over n, all right? And so in this case, that's the square root of 0.76. We already know that 1 minus p is 0.24, all divided by our sample size is 60. So we would divide that out, and if you divide that out, you actually end up getting, if you round it to 3 decimal places, well, underneath the square root, you end up getting 0.00304, and that ends up being 0.055 if you round it to 3 decimal places. So this is your mean of that sampling distribution, and this is your standard deviation of that sampling distribution. And it is normally distributed. All right, let's look at another example that involves finding the probability of a sampling distribution of the sample proportion. So according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. In a random sample of 120 Americans, so you have a sample size here, what is the probability at most 12% have hearing trouble? All right, so what we want to do is we want to, first of all, figure out if this is a normal distribution, okay? And in order to figure out if this is a normal distribution, we have to do the n times p times 1 minus p. And in this case, our n is 120, that's our sample size. Our proportion is this 15% that's given up here, so that's 0.15. And then 1 minus 0.15. Oh, that's 1 minus 0.15. So that's going to be 120 times 0.15 times 0.85. And if you multiply all of that out, that ends up being 15.3. And then remember the number that we check that up against is 10. And that is greater than or equal to 10. So since that checks out, then we can say that this is a normal distribution, okay? Our distribution for this probability of this sampling distribution for the sample probability is going to be normal because this value is greater than or equal to 10, all right? So now what we want to do is we want to, and I'm going to clear that out because now what we want to know is we want to know what is the probability. What is the probability that p hat is at most, so less than or equal to 12%, which is 0.12, all right? And so in order to find that probability, and since this is a normal distribution, then we need to standardize that value so that we can use our z-chart. So we need to find the z value for 0.12. Now, in order to do that, we have to know the population mean. So the mean of p hat, which in this case is going to be equal to the proportion of the population, which is 0.15. And then we also need to know the standard deviation of p hat. All right, remember that's equal to the square root of p, which in our case is 0.15, times 1 minus p, which is 0.85, all divided by n, which in this case is 120. So if you multiply that out, 0.15 times 0.85 divided by 120, you end up getting the square root of, it ends up being 0.00106. And I'm putting these values so you can check your steps as you work through this with me. And if you round that to, I'm actually going to round this one out to 4 decimal places because we use it multiple times. So we want to try to avoid a rounding error, but you end up getting 0.0326 when you divide that out. So that is your standard deviation. So now we need to find a z value that's going to be equal to our number of interest, 0.12, minus our mean, which is 0.15, all divided by 0.0326. And if you divide that out, you end up getting that to be approximately negative 0.92. Remember, your z-chart only goes to the 100th value, so we want to stop at the 100th value. So now we want to use our z-chart to find the probability that z is less than negative 0.92, so negative 0.92, 0.1788. So the probability that z is less than or equal to negative 0.92 is 0.1788, which is approximately 0.18. And so what that means is that if 100 random samples of 120 are taken, then about 18 of them will have at most 12% with hearing trouble.